In this next unit, we're going to talk about transformations. So the first thing I want to do is just review what transformations are. You've already talked about them in middle school, but in geometry, we're going to kind of review that, and then we're going to go further in depth with them. So the first thing is a transformation is some type of movement that's going to map what we call the pre-image, so the original figure, onto the image or the new figure. So if we look at the smiley face here, this would be the starting figure, which is called the pre-image. And then you're mapping this, or you're moving it onto this new figure, which is going to be called, the image. So that's what a transformation is. It takes one figure and it moves it by doing some kind of reflection or turning or sliding, and then you get an image. So when we talk about naming transformations, a convenient way to do this is by using what we call primes. So for example, I'll write a prime. It looks like a little 1 as an exponent, but to read this, you say a prime. And the reason why you would do that instead of just using a new letter is because then it's really easy to see where did a prime come from. So where was the starting figure? So if you look, this was a slide that occurred. This right here is the pre-image, the starting figure. And then this is the image, the result. So when we go to label it, A would go here. So that's A prime. B moves to this point here, which is B prime, and then C prime over here. So it's really easy to now see that A prime came from A, C prime came from C, and B prime came from B. And then the 4 types of transformations that you've heard of before. You have a reflection, which just means that you're flipping an object. A rotation means you're turning an object around a specific point. And a translation just means that you're sliding an object a certain distance and direction. These 3 transformations will not change the size or the shape of the original figure. So you can flip something, you can turn it, you can slide it, and it'll stay the same. So what we call these is we call these rigid motions, and that's going to be a big concept this year. So these are all rigid motions because they create figures that stay the same. So they create congruent figures. And then over here, a dilation, this is changing the size of the figure. So since it changes the size, it means that the figure is going to be what we call similar. So they're going to be the same shape. So if you look, it says keeps the same shape, but the size is going to change. It's either going to get smaller, it's going to get bigger. So this will not be a rigid motion. So it changes size, but it keeps the shape. I'm not going to rewrite it because it's right here. But this would not be a rigid motion. Now, if you look down here, another name for rigid motion is an isometry. So when we talk about an isometry, it means that it's staying the same shape and it's staying the same size after you perform a transformation. So rigid motion, isometry go hand in hand. So you have to just know isometries are reflections, rotations, and translations. Dilations are not isometry, not rigid motions as well. So it means it's a transformation that preserves length, or it's keeps the same shape and the same size. So when we say it preserves length, it means it's staying exactly the same. There's 2 types of isometries. There's something called a direct isometry and then an opposite isometry. An direct isometry means that the orientation is going to stay the same. So when we talk about orientation, that's the order, which really means the order of the letters. So order of letters stays the same. So if you look at this example here, a translation is a direct isometry. So what I like to do to see if the order stayed the same is just draw arrows in alphabetical order. So A to B, B to C, and then C back to A. And then if I go to the image and draw arrows as well, so A prime to B prime, B prime to C prime, going in that same order of the letters, see how the direction is going the same way, the arrows are pointing the same way. So these are called direct isometries because the order of the letters is the same. Now, an opposite isometry means that it's going to change the order of the letters. So change changes the order. So this is only going to occur when you have a reflection. So if you look, here's my example. Label the arrows on here. And then if I go in alphabetical order again, A prime to B prime, B prime to C prime, and back, see how the arrows are going in a different direction? So these ones go to the right, these ones go to the left. So that's why it's an opposite isometry. The only time that you're going to have opposite isometries is if you have a reflection. So I'm just going to make a note of that. So reflections are the only opposite isometries. So that means translations as well as rotations are going to keep the order the same. So I'm going to make a note of that. Rotations and translations are direct isometries. And reflections are opposite isometries. And dilations would not be an isometry because the size is changing. So you can't even look at the order of the letters because the size isn't the same, so it's automatically not an isometry.